Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today on the podcast, we have Arilla Barnes, who is the founder and CEO of Energy IoT Open Source. And I bet you that IoT stands for Internet of Things. And I'm a big fan of open source because I don't like all these software secrets. And it's just like when there's closed source software, which we're probably even using to have this conversation, that they can take it away at any time, they can spy on us, they can invade our privacy, they can take all of our data and put it in some place and turn us into AI robots. So how are you going to stop that, Arilla?
Well, I'm not trying to stop the AI robots. I just more focused on preserving energy, agency, and control of people over the AI robots. And Energy IoT open source is not just about open source at the software level, it's also about open source at the firmware and the hardware level. And what Energy IoT open source is trying to do is create turnkey solutions for microgrids, which will allow energy access to communities in a way that they can control those energy assets. To your point, like, how do I know what happens to my data, what happens to my energy, what happens to my investment in energy assets? And that's what open source allows us to do in combination with open standards. Like, I think you said you were in California. I'm a big fan of SunSpec Alliance because they're looking to standardize some important communication controls for distributed energy resources through standards like 2030.5 and SunSpec itself.
Yeah, great. Yeah, so I remember I was at this place that was formerly called Port Labs. Now it's called Informal Spaces over in Oakland, where it looks like you have an office. And there was some guy there, and he was working on some way to make one inverter communicate with another inverter. It was kind of complicated, but it sounds like that might be what you're working on.
Well, we actually have our first open energy lab at Informal Spaces in Oakland, California, Sean, thanks to a grant from Astera Institute. And it hosts our mini grid on wheels setup, which showcases a microgrid that can power a house or a street.
Oh, great.
In developing country. It has a solar carport that provides about 5.8 kilowatt of solar energy. That's comparable to what you'll get on your roof in California, like single home family, anywhere between 3.8 kilowatts to 10. What's the solar on your roof, Sean?
You know, I guess it depends on where I live. And so right now, I'm making a solar training center, and we just got the roof on. So we haven't got the solar on top of it yet, but that's in the works. Where I was living before, we were piecing it together, and I think there's 53 solar modules there, and it just keeps growing. Somehow it keeps on growing.
Wow, 53 modules, it's a lot. We have about 9. I believe that part of this carport, like I said, it's only 5.8 kilowatts. In my house, I have 3.2 kilowatts, NEM2 program, and also plug-in solar. Plug-in solar, it's about less than a kilowatt. So it's having an open energy lab that's accessible to the community, gives opportunities to see what it is and what it takes to have solar energy to supplement your home, or even to create an energy independence for yourself. We also have battery storage and hybrid inverter to take advantage of that solar array, and an EV charging station that's L2. So we have a complete set of components that will play in a microgrid for a household. And what's different about the Open Energy Lab is that all of those components are programmable through the SunSpec and the Mesh EMS open source gateway that allows to interact with each component, speaking the language of the vendor and broadcasting standard SunSpec on so that telemetry can be connected, analyzed, and leveraged for energy management scenarios, for example.
Mm-hmm. Great.
Or for providing billing functionality.
Yeah. You know what I've been going down a rabbit hole for lately is I'm in the process of getting a car, and I'm trying to figure out what brand of car will work as far as being able to export. So some people call it bi-directional charging. And kind of what I've come up against is like there's a lot of closed source electric vehicle companies. So for instance, Tesla, they're very closed source. There's General Motors, where they will allow you to export, but only using their inverters and software and their control. And they say like, oh, it's going to change, but it'll be retroactive, but nothing's in writing. So how do you invest in something like a car and not know if it's for sure, if you're going to be able to export? And I'm trying to, set it up with the Solar Training Center here too. And then there is the one that I'm kind of leaning towards is there's the Ford Lightning electric pickup truck, and they've stopped making it, unfortunately. So there's no 2026 model, but I can get a used one. And originally when they came out with it, they had their own Ford proprietary inverter that connects to the DC part of the battery, and you couldn't get in there. But they stopped making that, and apparently they've started letting other people connect to it. And so there's something called SIG Energy. Enphase is supposed to come out with something soon. There's others out there too that they say like it'll probably work, but then the question is, what if Ford just says, we're not going to let you do that anymore? And then I believe that Rivian is going by the International Standards Organization, so ISO standard for exporting, and that will work with like pretty much anything, but then nobody's doing it yet as far as like being able to connect to the US grid. I think I could get one that would connect to the European grid at 50 hertz. But it's been quite a rabbit hole that I'm jumping down there. So what do you think about the, whatever they call, bi-directional EV charging and trying to get in there and do that? And everybody says like, oh, we're going to have it next year, next summer. And then they keep putting it off and delaying it.
Well, like you said, it's already a reality in Europe. The technology is there. It is reflected in the standards related to EV charging. And Energy IoT Open Source is also a partner of Linux Foundation Energy. And one particular project under Linux Foundation, Energy Everest, is the key holder of all the interoperability and the latest and greatest standards related to EV charging in open source. So I would say check what standards are supported or advertised to be supported by the vehicle of interest and see how that maps to the roadmap of Everest. Is it available? So that's step one. It's a very low level block because that works at the EV charger level, at the firmware level. However, it's the starting point of talking to any vehicle and exposing features like bidirectional energy movement. And that's another thing that the Open Energy Lab can enable. It's a safe way of testing these kind of open source protocols. We do have inventory to build a second microgrid even, and to show how we can trade energy between one battery and another, or trade energy between an EV and the battery by incrementally loading and testing these open source components and making them a part of a bigger energy management system, whether it's like charging energy management system. And good news, there's open source called Citrino-S in that space, or a behind the meter energy management system, Flex Measures, OpenEMS, open source systems that allow that. And what Energy IoT Open Source is trying to do is work with entrepreneurs, whether they're in Oakland or in Uganda, to put together these end-to-end solutions for specific use cases, whether it's resiliency, whether it's submetering, whether it's a village microgrid, or like you said, can I take advantage of my car to help my house needs in the case of a blackout or vice versa. That's what can be tested safely, and we would love to expand that capability to other similar co-working spaces in California, US, and the rest of the world.
I have an idea that we should make our politicians require that all electric vehicles are able to export with some kind of protocol where you can just connect to the battery. I'm pretty sure it's just a software issue. I knew somebody that was working at Tesla that I bought a used car off of him, like, I don't know, like it was a 2015 Model S, and I bought it probably like 6-7 years ago. And he said that it was just a software issue. And it kind of makes sense. You could do fast charging, you're connecting to the DC battery, and you could just connect to that battery and then export too.
I'm not sure it's just a software issue, Sean. It's also safety. A lot of it is about safety and how you navigate the different voltage differences, and also regulations, like what the utilities are comfortable allowing in any particular community. And what I've noticed is when, from a utility perspective, solutions that allow to keep the control centralized with the utilities when and if an EV owner can contribute to the grid is favored. And I have different opinion that in places where a grid does not exist, there's also opportunity for different distributed autonomous microgrids that can trade and share energy within the nodes that the microgrids are connected to each other. And you can view an EV as a microgrid and a house as a microgrid, and the two microgrids can share energy. That is possible through today's technology and protocols. However, the regulation lags behind. And again, it's also education. Not many people understand what a microgrid is, that every time you can match consumption of like what your device appliances use, whether it's a computer or refrigerator or air conditioner, and where the energy to power that comes from, whether it's your solar roof, your car battery, or gas generator, or the utility meter connected to your house, that's not quite understood. And what is the difference when it comes from the utility and what it comes from a system built to match consumption, whether it's a house, a church, or village.
Yeah, we need to get these politicians to open source everything. I think there should be a new political party called the Open Source Party, and we just open source it all.
I would love that party, and I believe that is the true test of democracy, is when you have transparency. And open source has shown for several decades now with Linux and Linux Foundation and the Linux operating system, that's when you have the oversight of a million eyes. You end up not only building a very strong and secure product, it's also very affordable and available product that enables opportunities for people that can never even dream about it in a closed source system. So definitely, I fully support more transparency and at least having open source benchmarks. So basically, if there's an open source solution, as a commercial solution, can you prove that your solution really has the value add to charge the premium price? And open source can be that minimum requirement of a product or a service that satisfies 80% of the needs or 90% of the population, especially when it's a vulnerable population and reserve proprietary for things that we want to keep away from the public eye, right? When we want to be on the defense, we don't want to open our cards.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
Yeah, I've even heard that you can't even put an extension cord over your fence. I mean, I guess it would be different in different states. So you can't even put an extension cord over your fence to share your electricity with your neighbor because the utility has that right and you don't. So it just seems like we should be able to share our electricity with our neighbors and have more things like virtual net metering and stuff like that. And then we should be able to tap into our car batteries. It's such an underutilized resource. And I kind of think that there's probably the utilities don't want to do it because they want to be in control and, you know, they want you to buy electricity from them. And then a lot of the car manufacturers, they say like, oh, it'll void the warranty of the battery or something like that. But the batteries for electric vehicles, they're ours. We should be able to do what we want. Even if it does void the warranty, we should have that right to void our warranty and do it. And it would be neat if maybe there could be some kind of software where you could sort of hack your car and make it so you could touch that battery. And I don't really think it's that much of a safety issue because when we're doing DC fast charging, you know, some people call it supercharging, and you go in there and you can charge up like a big old battery in a short amount of time. So you're talking like hundreds of kilowatts going to that battery to charge it. So if you're like, you know, if you want to connect it to your house, you're only talking about like maybe 10, 20% of that, you know, where you're going to do like 10 or 20 kilowatts, probably even less than that on average, when you're going to go out and perhaps power your house or send something out to the grid. And really, it could support the grid as, you know, like some kind of virtual power plant, or when the grid needs it, you can give it some electricity. So it just seems that we need to change our society and open source the government.
Well, I mean, the virtual power plant has been around for about 5+ years at least. And the way it's handled is through intermediaries. And one way of handling is the open ADR standard. Again, it puts the utility in control, and it has aggregators and arbitrators in the middle, which gives you like a day ahead at best reactivity to the market. There's attempts to bring that closer to the within a day with Octopus and Uplight, kind of trying to, again, have a central control of the devices in a home, whether it's EVs or thermostats, etc. So that is like, how can we help the grid? There's a lot of companies working on that in partnership with utilities. And that space has been addressed. To your point, can we have the wire cross to our neighbor? That is illegal currently, but that was, again, laws and rights that were designed when the most viable solution for energy was centralized. That has changed today with renewable energy. Every consumption point can also be a generation point, meaning that a lot of the mass loads that are part of the complex distribution networks that the most challenging for utilities to manage and control now can be self-sufficient with investment in plug-in solar, investment in batteries, even micro wind or micro hydro based on landscape geographies, etc. So that has changed the game and has potentially can change the market. And again, it's people, I am advocating for the same rights. If I'm an energy asset owner, I should be able to control that asset and trade with that asset output the same way as any utility. And that is possible because of digitalization, just like each of us can access a social media app or have a spreadsheet, whether we are an individual or corporation, we have the access to the same features.
Mm-hmm. Great. So some of the things that you did mention, maybe I would just ask you about them. So I think you said the Linux Foundation. Did you mention that?
Yes.
And so maybe you could tell us what that is and how you work with the Linux Foundation.
Linux Foundation has been around for a while, and it's founded by Linus, the founder of Linux operating system. It also has other subsidiaries like Linux Foundation Energy, which was spearheaded by Dr. Goodman right in California about 10 years ago, on the mission to create more open source collaboration between utilities and different energy frameworks. So whether it's like grid modeling or grid operations or synthetic consumption data or peer-to-peer energy trading, as in DC Microgrids, which is the project that I lead at Linux Foundation Energy, all of those projects are looking at the current energy situation, that it will take all levels of consumption and all energy use cases, to work together and collaborate to make sure we don't fall behind on energy when AI is stepping up and demanding huge data centers to be built in the next 5 to 10 years. You probably have seen how that has jumped in consumption, regardless of forecasts. Also, anytime there is global conflict event or disaster event, that is setting everybody back by destroying infrastructure. So whenever war conflicts are destroying infrastructure, how do you rebuild that in a way that's efficient and catches up?
So you work on the Linux Foundation? I guess you said Linux Energy?
Linux Foundation Energy project, specifically LF Hyphae, and
Great.
also LF Open Leader. Those are the two projects that I've been closely involved with.
Oh, that's pretty neat. And do you know, like, our data centers, are they run on Linux? Like some sort of Linux software?
Probably. I mean, it's very different ways of designing data centers. They all need some level of operating system. Some companies have optimized even that level, like depending on what is needed from a compute power. So there's a lot of levels of optimization. I'm a big fan of what Utility Data is doing. I was former VP of engineering there. And Utility Data has a platform for optimizing energy through AI in the data center, so the consumption can be improved without additional investment in utility infrastructure. And I think that is also big. And that's what I'm saying. There's many ways of solving the puzzle of matching energy, and it's better to collaborate and allow everybody to move in their lanes, whether they focus to do the 10 kilowatt or 100 kilowatt space, is what Energy IoT open source is looking into, or the data center use cases, which are in the megawatt and terawatt, gigawatt space.
Yeah, I remember like making some little mini computer that would connect remotely to my computer. And I remember flashing Linux onto it. So it's like I take a little card or like a USB and I stick it into my computer, and then it puts it onto this other device. And I bet you're probably really good at that.
Well, me personally not. I can do some flashing, and the Mesh EMS that we have, it can be flashed with the firmware. The firmware actually, it's not an operating system. It's much smaller than that on purpose, because we're trying to take advantage of a very, very cheap compute, the ESP32, which is about $10 a chip. A Raspberry Pi, it's a little bit more involved, and we also use that one with Linux. So that's where we will run an energy management system like OpenEMS Edge, and that's slightly more expensive compute, like say about $100 to $200 per unit. And you can go from there, like GPUs and Jetson Nano. They're tiny, but they're pretty expensive. And again, it's possible to put, and that's what I would love to do next Open Energy Hackathon event, is see if we can build the data center on wheels, if we get some donations of GPUs, and see how many compute racks we can wire together to be powered by the 5.8 kilowatt microgrid we have at the Open Energy Lab. And that gives you a distributed local data center scenario that can leverage, has a different execution path that a centrally managed and planned a data center can take years and millions of dollars to put together.
That's really cool. And so distributed data centers, and I actually, before I ever heard of it, I thought I invented it because I was like, we need to have, just like we have distributed energy, distributed computing. And now I even see that I think SPAN is working with some home builders and they're putting data centers in new homes. And so when you have extra electricity that you're not using, it's like most people have a 200 amp service and they're using 5 amps on average throughout the whole year. It spikes up and down. So a lot of the times you have tons of extra grid capacity that you could use to make a data center work at your house. And then there's all this problem with like big data centers coming out and taking up farmland and getting people upset. And we could just do it at our house and make extra revenue. And then I was even thinking too, because I always think of like a vehicle is a battery on wheels, but also, especially as the future keeps going on with self-driving, a vehicle is also going to be sort of like a data center.
Data center.
Yeah.
The amount of data it processes to be able to handle autonomous type of activities is on par with a data center just 10 years ago that was running a bank.
Uh-huh.
So it's like the miniaturization that is happening in compute, and also the advances of networking that you can have 6G, 5G, and Starlink, that allows to start entertaining distributed scenarios of compute, maybe not for mission critical and military type of applications, but why not handle the compute needs of the local businesses also locally?
Mm-hmm. Yeah, it just seems like we take these big pieces of metal, they called cars, and we zip them all over the place. And the most efficient way to do it is electric. And we drive our cars like a very small percentage of the time. And now these cars are taking like these big computers. It just seems like a perfect situation to coordinate all these things together. And then it's my prediction that your company is going to make it happen. And then you're going to become like the world's most famous CEO. I think that's what's going to happen.
That will require a significant amount of funding. I am chipping at the problem with my small but mighty volunteer team and donations. I would love to, like I said, partner and entertain hackathon events and sponsored open source projects. Sean, what I call sponsored open source is like if there's a deadline, if something wants to be accomplished on a certain deadline, it needs to be sponsored. People need to not worry about their healthcare insurance or their utility bill to focus on the problem at hand and execute when the mission resonates with them. With volunteers, we can keep moving in a direction, but we never know when we'll reach that direction and how many hands we need to do. I'll give you one example. Energy IoT Open Source rescued and resurrected a project donated to Linux Foundation Energy by Sony Computer Science Lab 5 years ago. So 10 years ago, they were able to do 10-house microgrid in Okinawa University, and this is faculty housing. So these are modern Japanese houses with all the creature comforts connected with the DC microgrid. So everything, there's no AC distribution lines. There's DC cables running between the houses connected through batteries and solar panels on the houses so that not only they can manage the device loads inside the houses like refrigeration, air conditioning, cooking, etc., but also if some houses were not occupied, or they can trade energy between the houses based on the state of charge in the batteries through the DC microgrid. And I was fascinated with that project and been trying to resurrect it and update it for the last 3 years through volunteers and mentorship programs. And I'm at the point now that I would like to actually test it in the energy lab with two microgrids. Like I said, I have one and I have the parts for another. So that we'll be able to test this peer-to-peer energy trading and see what else we can enable on top of that. But that's just an example that when there's open source, but there's no sponsorship, it can sit on a shelf until somebody comes that can understand and bring it back to life. And that doesn't always happen. There's a lot of projects that end up in open source graveyard. Some of them were meant to be there, but some of them are just a little bit ahead of their times and just a function of no funding.
Shawn White's Solar and Energy Storage podcast was brought to you in part by Carrots. What's up, Doc?
So I have an idea. Maybe we can work together. I live on this property where we're building the solar training center, and there are a bunch of people living here in different places. There's some houses, some trailers and things like that. Maybe we could put something together just like that Japanese project that you're talking about.
I would love that. Shawn, let's make it happen.
Okay, if this wasn't a Zoom call, I'd be shaking your hand right now. All right.
We do the virtual handshake, and there's also contracts and MOUs that we can do digitally and get it going.
Yeah, I think this would be perfect for that. And some other things that I have that I'm trying to set up, it's a big job, is pumped hydroelectric. It would be sort of like a demonstration project, but we have two reservoirs that are, at different elevations. We have a well with pumps, and so we could pump the water when it's less expensive.
Oh, hydro pump is a great storage. It's a great technology for storage. So batteries doesn't have to be a lithium battery. It can be a hydro pump storage. It can be even like cement blocks.
Oh, I like water. We can make waterfalls.
So there's many ways of addressing storage, and there's lots of companies. That's another thing I've been doing, is collecting these entrepreneurs and technologies from across the globe. And like I said, there's a lot of innovation, a lot of effort of energy access and affordability around that. It's open source and non-profit. Energy IoT is open source based and non-profit for a reason, because entrepreneurship doesn't always get you crossing the chasm. I was innovation leader at Veloce Energy. We made it to Series A, created some great grid edge and storage technology, and died on the fundraising round. And I believe that technology you can see it somewhere else, but for the new entrepreneurs, they just start over again. They're rediscovering the wheel to get to table stakes, to be compliant with standards, to show safety and basic use cases. And that's where we can collaborate through open source and enable entrepreneurs to develop and support the markets, like develop and support the center that you mentioned, or the next center like it. That market that organically grows and expands with local entrepreneurship. That's not something that Energy IoT Open Source wants to own. We want to support and collect that, be the custodians of that collective wisdom to enable the next entrepreneur in the next country, so we don't lose any time in the face of climate changes.
Well, that's great. I'm so glad that we have this recorded, because a handshake on a recording is definitely binding. And so you mentioned a few times Open Energy Lab. Do you want to explain what that is? And then can this location be part of your lab?
Yeah, Open Energy Lab, like I said, is hosted currently at Informal Spaces in Oakland, California. And it has this programmable microgrid that I mentioned. We have a programmable interface thanks to the SunSpec and the Open Mesh EMS module that was advanced by Nestle Energy, one of our entrepreneur collaborators. And we are able to talk to the EV charging station. We're able to talk to the inverter and create interesting scenarios. And that has been demonstrated through our hackathon events and allows people to interact with that technology, whether they want to validate a proprietary equipment that they want to take into commercial scenario. For example, Microgrid is another entrepreneur that was contributed to Energy IoT open source in the process of hardening their commercial product, or just to learn like what is possible. Like you said, hey, can we trade energy? We heard about this great thing in Japan. Can we see it locally before we invest at the scale of a 100 kilowatt community? Can we prove it with 2 5 kilowatt systems on hand first, and then take those learnings and multiply them?
Mm-hmm. Right. I think that you're sitting in a really good position. I think that like just the evolution of what's been happening with this industry, we first had incentives, and that got the solar going, and then the economies of scale brought down the prices, and then we have so much solar, we need to start storing it, and so we're storing it in batteries pretty much, and then we have all this solar and storage and batteries, and then we need to coordinate everything, coordinate the loads, coordinate the solar, coordinate the storage. Storage includes four-wheeled storage. I think most of the batteries are on wheels that are just not being used 95% of the time at least. And I think that like what you're doing and what your industry is where a lot of people should focus on the future. I think what you're doing is the future. How is the future?
Well, I think the future is definitely, I have a very positive outlook. I believe with the democratization of solar panels and batteries, by the way, the cost has dropped significantly. Now we have more the problem of regulations and tariffs, that barriers to energy independence and energy access. And I believe it's continuing to enable rights and access and equal access to markets for all energy owners. And whether they are a household in California or a community in Africa, it's like if you own the energy and you consume energy, what's the most mindful way of reducing the carbon footprint or the effect on the environment or the effect of your neighbors? What does that look like? And it's not a central coal-powered plant anymore. There's other options available today.
Like my little rooftop coal power plant, the one that I have sitting outside.
Actually, I'm also a big fan of biomass, like biofuel. Like you can turn your composting or your favorite farm into biofuel for your community. More power to you.
Yeah.
I said it's a more mindful way of using the mix of fuels available to us today, as opposed to saying, oh, we're just going to do this or we're going to just do that. There's a good use for nuclear power and a good use for gas generation and oil generation, and there's a good use for solar and wind. And optimizing the mix of those is what I see as the future that will prolong our energy availability rather than face a crisis.
Great. Okay, so when are we going to get started with our new facility out here, our project? You ready to go?
Yeah, I'll be in California June 5th. So we can book that day and we can talk about it all day.
That sounds great. And then if you ever want to be on the podcast again, we can do that too.
Cool. Thank you. Happy to join you again.
All right, Arilla Barnes. And then how can people find you and help you and get involved?
They can reach to me at my email, arilla@eiot.energy, or our website, www.eiot.energy. So it's like energyiot.energy, but abbreviated.
And so what is it that you need from people besides a place for our demonstration project, like funding, stuff like that?
Well, funding is top of our mind. It's like I said, we had a grant to get us going at Informal Spaces in Oakland. How do we make that a permanent fixture in Oakland is top of mind. And also it will enable to scale our model of mentorships and entrepreneurships by having a dedicated staff for Energy IoT open source so that we can increase the impact.
Great. Well, Thank you so much, Arilla Barnes. And Arilla is the founder and CEO of Energy IoT, open source, soon to be the most popular, important CEO in the universe that anybody ever saw. So you heard it here first. I'm sure it's all going to happen, and we'll see more too. I can't wait to see you in June.
Thank you, Sean.
Yep.
Thank you for hosting me today.
Okay.
And appreciate your time.
All right. Thanks a lot.